Alright, so self-induction, let's continue the discussion on self-induction. So first you as I told you, the circuit, that is a coil is there and the magnetic flex, magnetic field is represented here, magnetic field, and the current is passing through it. Okay, so let's talk about this one. So let's phi b is the magnetic flex linked with this circuit in each term. Okay, phi b is magnetic flex linked with each term. Okay, not first for one turn it is phi b, and n is the number of turns. Okay, so from what we have discussed, it is very clear that n phi b, that is total flux linked with the circuit, is directly proportional to the current passing through it. That is what we were discussing, right? So in self-induction, so again, so n phi b is equal to change this proportionality into equal sign. So let it be L into I, and also L is equal to n phi b divided by I. So this is what is the first equation or first derivation of L. What is L? L is known as self-inductance. Self-inductance of the coil. So one thing is very clear, that inductance is that property, inductor is the that device, that material, that conductor. Okay, so you can say that inductor is the device, inductance is the property, same as resistance and resistor. Okay, so in the same way, since it is a self-induction, so we can call it as self-inductance of the coil, or we can also call it as coefficient of self-induction. Coefficient of self-induction. Okay, and also I would like to explain it in another way. So let's say N is equal to N into d phi b divided by I. So let me say that suppose N is equal to 1 and I is equal to 1 ampere. Okay, so then what will be L? L is equal to phi b, which means what is self-inductance? Self-inductance is nothing but it is the total flux linked with the circuit, linked with the coil. So when the current passing through it is 1 ampere. When the current passing through it is 1 ampere. So you note down that what is self-inductance? So you can define self-inductance from this equation. It is nothing but it is a flux linked with the coil when the current passing through the coil is equal to 1 ampere. Alright. So again, let's come back to the Faraday's equation. What is Faraday's equation? E is equal to d phi b divided by dt, and we know that by using the Lenz's law, minus sign we have to add, right? Yeah, minus d phi b divided by dt. And again, what is d phi b here? N into phi b, because n is the total number of coils and phi b is the flux linked with one coil. Okay, divided by dt. And you can also look at this. What is n phi b? This is Li. So you can apply the value Li here. Take L outside because it's a property of the coil and it's a constant. So minus L into di by dt. This is very important equation. E is equal to minus L into di divided by dt. Also, what will be L? L is equal to minus E into di, minus E divided by di divided by dt. And also, I would like to explain, or I would like to define the self-inductance in another way. That is, L is equal to minus E divided by 1 when di divided by dt. So let's say di by dt is equal to 1. What is the unit of di by dt? 1 ampere per second. Okay. So then what is L? What is self-inductance? You can define self-inductance again. Self-inductance of the coil is equal to the total induced EMF in that coil. Okay, total induced EMF in that coil when the current passing through the coil per second, or the rate of change of current in that coil is equal to 1 ampere per second. You can define in that way also. So what is the definition? The L is equal to the self-inductance of a coil is equal to the induced EMF when the current passing through the coil per second, or the rate of flow of current is equal to 1 ampere per second. Okay, so this is what is self-inductance. And also, why this minus sign? Again, there will be a question, one more question. Why this minus sign? Because this current, this induced EMF, will always try to oppose the change in current. Again, this change, like due to that change in current, that is the induced EMF is producing. So the induced EMF will always try to oppose the cause of that EMF, cause of the change in flux. So that is why E will always try to oppose. E will always try to oppose I. Okay. So that is what is the basics of self-induction. And remember these equations. And we'll talk more about self-inductions and then induction, then mutual induction. Okay. Thank you.